Ladies and gentlemen, this video is made so you could do better on the final. We are going to explain the practice final. Here we go. Number one, you want to find g of h of x and h of g of x. Again, you want to plug in the h of x function into the g of x function, okay? So what we're going to do is plug in this h of x function into the g of x function, and that will give us, so let's rewrite our g of x function, but instead of x we're going to put parentheses, and of course it has a plus 6, so there it is, x plus 6, and we're plugging in this h of x into the g of x. So this 3x squared is going to go right in there, which is why we have the parentheses right there. We're going to put a 3x squared right in there, and of course there is no multiplication, so it's really unnecessary to put the parentheses there, and that is your answer, because you can't really add 3x squared with 6. You can't combine like terms. This is your answer. That answer is to g of h of x. G of h of x. Now let's do it the other way around. Let's plug in our g of x function into our h of x function. That's read h of g of x. So let's take our g of x function, which is right here, it's the x plus 6, and let's plug it into our h of x function, and of course we're plugging into the actual x. So the way to do that, the best way to do that is to rewrite it, 3x squared, but notice instead of the x I actually put parentheses, and I am plugging in the x plus 6 right in there. Now this will take significantly more work than the previous one. Why is that? Because inside of the parentheses there's nothing to do. I move on to e exponents. So you have a binomial squared. That means that you need to write it twice. Now let's not forget about that multiplication of 3 out in the front at the very end. But for now, what I'm going to focus in on is this, the x plus 6 squared. So we have x plus 6 times x plus 6. That'll give you x squared. That'll give you 6x. And that'll give you 6x, and 6 times 6 is 36. So what we have here is, let's not forget about that 3 that we said, this 3 times. We're going to say 3 times, but we have, let's put it inside brackets or parentheses, we have the x squared, and of course the, let me highlight it here, 6 plus 6, that's a total of 12. So we have plus 12x and then plus 36. Now, again, we still need to deal with that 3 that's out in the front. So we're going to take that 3 times x squared. It is 3x squared. 3 times 12 is 36 with an x. And last but not least, 3 times 36. Whoops, I didn't draw the arrows. Sorry about that. 3 times 36, that is 108. So ladies and gentlemen, that is our answer right there. Again, this one was the h of g of x. H of g of x. And of course, this is a multiple choice problem. So let's see. Does not exist? No, they both existed. So let's see. We have 3x squared plus 9, and that was not it. It's 3x squared plus 6. So where's 3x? Here it is. That's the first one, the g of h of x. And the next one is, or the second one, h of g of x is 3x squared plus 36 plus 108. Again, I'm just verifying, and I'm verifying. Okay, so that is the correct answer. Voila. So far you have an A+. Find the inverse. Ladies and gentlemen, what does it mean to find the inverse? Switch x and y and then solve for y. So you might be thinking, whoa, where's the y at? It's right here. F of x is really the same thing as y. Okay, so what we have is, instead of writing y equals, let's actually start with that. Let's write down y equals x squared plus 5. And we're going to do what it says for us to do. Finding the inverse, you switch x and y, then solve for y. So we're going to magically switch these guys, and you'll have a x equals y squared plus 5. And now let's get y by itself on the right side of this equal sign. So we're going to subtract 5, Of course, that cancels out. And x take away 5, you can't do that, so you're just going to rewrite it. X minus 5 equals y squared. For the final step, you want to get rid of the square on the y, and to get rid of anything, you do the inverse operation. The inverse of a square is a square root. What you do to one side, you do to the other side. But remember, whenever you apply a square root when solving an equation, you have to put a plus or minus in front of your answer. So what we have here is y equals plus or minus the square root of x minus 5. And of course, it looks nicer if your y equals is on this side instead of this side. So I'm going to erase it. Now it looks nice. So which one is the correct answer on number 2? By the way, they have the inverse notation right here. F, it's not f to the negative 1 of x. That's the inverse of y, or the inverse of f of x in this case is plus or minus square root of x minus 5. So option A is the correct answer. Moving on, number 3. Of course, when we simplify radicals, what we need to do is rewrite whatever's being multiplied in here. We need to split the root to each of those items. So we have the square root of 45, we have the square root of x to the 3rd, and we have the square root of x to the 8th. Wait, y to the 8th, I'm sorry. Not x, that's just a y. Okay, so when we think of the square root of 45, we wish that were the square root of 49, right? If it were a perfect square number, the answer would be perfect. But in this case, it's not a perfect square number. So the question is, could we rewrite it with multiplication to get a perfect square number? The answer is yes. We could rewrite it to 9 times 5. Okay, and then we're going to split the root, put it on each of those terms. The square root of 9 is 3, and the square root of 5 comes down. So technically, that's saying 3 square root of 5, which actually means 3 times the square root of 5. Anyway, on this next portion, we need to remember the fact that, and let me write it over here, the square root is really the power of 1/2. Okay, the 3rd root would be the power of 1/3. The 4th root would be the power of 1/4. So if you're dealing with a square root, we would love this power to be divisible by 2. Or maybe we remember the other set of notes that when you have any base to the power over root, when you have a rational exponent, the power, the numerator of the rational exponent is the power, and the denominator of the rational exponent is the root. So what we really have here is this root of this same base to that power, okay? So when we think of this, you could think of it as x to the 3/2 power, or you could simply think of it kind of like what we did here, where you want it to be divisible by 2 because we know that the square root is really the power of 1/2. So we would want this power to be divisible by 2. And just like over here where we wanted a perfect square number, we rewrote it with multiplication to get a perfect square number. Right here we would like a power that's divisible by 2. So let's rewrite it to get a power that's divisible by 2. I'm going to rewrite it as x squared times x. And then I split the root. And of course, I will get the square root of x squared. That's just a nice, beautiful x. And the square root of x comes down. And that technically means x times the square root of x. Last but not least, over here, it's already beautiful. Y to the 8th, that is already divisible by 2. The power of 8 is divisible by 2. So if you really wanted to show your work, you would say y to the 8th to the 1/2 power, power to a power you multiply, you end up with y to the 4th, because 8 times half is 4. So what we have here is a bunch of multiplication, right? We have 3 times the square root of 5 times x times the square root of x times y to the 4th. So let's just rearrange it. Commutative property of multiplication allows us to do that. We have 3x y to the 4th times the square root of 5 times the square root of x. We might as well put those together. 5x, square root of 5x. And there is the answer that we should be able to find on our multiple choice answers. It's not that one. It is this one right here. Bingo bango. All right. That you see, it's easy. Okay. Number 4. Let's simplify. Let's begin by rewriting 8 square root of 48, but instead of the square root of 48, I'm going to rewrite it as 16 times 3. 16 times 3. That allows us to split the root to each of those. But let's just continue on here. Minus 6, and the square root of 75. 75 is not a perfect square number, so let me rewrite it with multiplication to get a perfect square number. 25 times 3. And last but not least, we have the plus 7 square root of 80, but 80 is not a perfect square number. So yeah, we could rewrite it as 4 times 20, but take a couple more seconds and think of a higher perfect square number, like 16 times 5. That also gives you 80. And of course, you could use a calculator. So now let's split these roots and simplify these radicals, okay? So when we split it, we will get 4 square root of 3, which is really 4 times the square root of 3. But let's not forget about the 8 that's out here in the front. So you really have 8 times 4 times square root of 3. That is 32 square roots of 3. Let's do the same for the next one. Split square root of 25, square root of 3. You end up with 5 square roots of 3. And let's not forget about this minus 6 that's really in front that you need to multiply the 5 by. So you end up with minus 30 square root of 3. And last but not least, let's split the square root of 16 and the square root of 5, split that square root. And you will have 4 square roots of 5 with a 7 that you need to multiply by out in the front. So that's really plus 28 square roots of 5. Now, out of these simplified radicals, what could we combine? Which are like this first and second one. 32 of these guys, take away 30 of these guys, will only leave you 2 of those square roots of 3's left over, right? Plus, bring down the 28 square root of 5, and you are done. All you got to do is find it on your answer, and they might have written the 28 first. I don't know. No, they didn't. Here is the correct answer. 2 square root of 3 plus 28 square root of 5. Option D. Numero 5. All right, so we need to remember rules of exponents. You could take whatever you'd like and move it up to the other side as long as you change the sign of the exponent. So what we really have here is q to the 3/5 on the top. Q to the 3/5 times q to the negative 2/5. All right. Now, you got to remember the first rule of exponents, that when you're multiplying two terms with the same base, right, q and q, you could actually combine the exponents, right? I mean, x to the second times x to the third is x to the 5th. So we know we could combine it, and we'll have our new exponent up here on the power of that single base q. So let's combine 3/5, take away 2/5, and that's ridiculously easy. 3/5 combined with negative 2/5, because you already have a common denominator of 5. So you could simply go 3 take away 2, and that will be 1, as in 1/5. So you have q to the 1/5 is your final answer. Option D. Alrighty, moving on. Number 6. All right, let's start solving this guy. Now there's more than just solving this entire inequality. There's something else we have to do. We have to do something with the radicand, but we'll get to that in a little bit. All right, let's first just solve it the way we normally would. Subtract 9. You will have the square root of 3x minus 5 is less than or equal to, what is this, a 5? Yeah. And now we want to get rid of the square root, so we do the inverse operation, the square. What you do to one side, you do to the other side. You will have 3x minus 5 is less than or equal to 25. Let's continue solving. Plus 5 here, plus 5 there. You will end up with 3x is less than or equal to 30. Final step would be to get rid of that multiplication of 3 by dividing by 3. You will have x, you do not flip it because you didn't divide by a negative. X is less than or equal to 10. Okay, that's one answer so far. And some of us might get that and then they think, oh, there's my answer, I'm done. Wrong, right? Okay, why is that? Because this is a radical inequality, and we know that since we have a variable in here, we know that we cannot end up with a negative value inside. The radicand, maybe I shouldn't refer to it as a radicand value, but the value inside the square root should not be negative, because we know that the square root of a negative is imaginary, and we don't want imaginary answers, we want real answers. So we need to set this binomial 3x minus 5 to be greater than, or at the very least equal to 0. Okay, so you have to solve it the way we just did, and in addition to that, rewrite it 3x minus 5 and say that that inside value of the square root has to be greater than or equal to 0. Okay. It is a radicand value, so we could use that vocab word. Let's continue solving here. Plus 5, plus 5. We have a 3x is greater than or equal to 5. Final step, divide by 3, divide by 3. Again, you don't flip the inequality. X is greater than or equal to 5/3. So there's our other answer. So what we must do now is go to a number line and think about the areas which these answers represent. So we obviously have a 10 right here, and let's say 0 is over here, and obviously 5/3, that's going to be almost 2. So right here would be 5/3, roughly. Okay. So this guy, I'm going to do in blue. It says x is greater than or equal to 5/3. Greater than or equal to, solid dot going to the right, right? Greater than to the right. And this other one I'm going to do in red, x is less than or equal to 10. Less than is to the left. So there's 10, less than is to the left. So as you can see, this is an area that's enclosed. So if it's an enclosed area that's from here to here, all you have to do is put the x in the middle and put the less than or equal to symbols between both of those. So here is our answer. 5/3 is less than or equal to x is less than or equal to 10. Okay, and there it is. 5/3 is less than or equal to x, which is less than or equal to 10. Man, a bunch of answers that are the final option D. That's weird. Moving on. Number 7, which function represents exponential growth? So I hope we remember exponential growth functions. They look like this. Y equals your a value times the b to the power of x minus h plus k. But then again, when they're asking just either for growth or decay, what do we look at? We look at the b value, at this b value. So we know that if that value is greater than 1, then it's going to be a growth function. Okay, because think of it this way. If you take any number and multiply it by any number that's greater than 1, like let's say 1.5, it's going to be greater, right? 20 times 1.5 is going to be greater than 20. 20 times 2 is going to be 40. 20 times 3 is going to be 60. So any value that's greater than 1, it's going to grow, and that's what we're looking for on growth functions. If it were a fraction that's between 0 and 1, then that would cause a decay, right? Like let's say it was a fraction that's less than 1, like 1/2, right? Then that would be a decay function. Take any number like 20 and multiply it by 1/2, it's going to decay. The 20 is going to shrink down to a 10 if you multiply it by half. So again, the base, if the base is a value greater than 1, then it's going to grow, and that's what we're looking for. If the base is a value that's between 0 and 1, like a fraction or a decimal that's between 0 and 1, it's going to decay, all right? Anyway, this is a fraction that's between 0 and 1. That's going to be a decay. This has the x in there when we know it should be an exponent. That can't be it. This has the base 3, which will definitely cause any number to grow if you multiply it by 3, right? 5 times 3 grows to 15. 10 times 3 grows to 30. So this is the growth function. That is our answer C. And guess what? It's not D. All right. Anyways, this option D is definitely not a growth function because 3/5 is less than 1. And yeah, it's greater than 0. But if it's less than 1, it's going to cause it to decay. Number 8. Identify the asymptotes, the domain and range of each function. Okay, so I hope we remember the form of these reciprocal functions. There it is. Or, of course, we could also take, you might see it with that a value being written up here. After all, if you put like a over 1, like if this were a 5, you put 5 over 1, and then you'd have to multiply 5 times 1 to get the 5 up here. So it is possible where you see the a up there, and then x minus h, and then plus k, all right? So anyway, what is the a value? The a value is 1, which means that it's not -1, which means that it doesn't reflect over the x-axis. So you will have the reciprocal function graph down here, lower left and upper right. That makes total sense, okay? What else do we know? We need to know the asymptotes. So we need to remember that the asymptotes is x equals the h value, excuse me. So x equals the h value. And in this case, that's going to be x equals +1. Okay? So what we need to do is think opposite of what we see here, right? Because it says x minus h, that minus sign means think opposite of what you see. So think opposite of what you see here. So the x really does equal 1. X equals 1 is the vertical asymptote. So as you can see right here is 1, and that is the vertical asymptote. I'll actually put a dotted green line right there. Okay. And then the horizontal asymptote will be y equals k. All right, y equals, let me put a red k right there. So that's really y equaling the k value of -3. You take that for what it is because it's a plus sign, not a minus. Not telling you to think opposite of what you see. So there are two asymptotes, x equals 1 and y equals -3. The domain, well, let me actually graph that asymptote of y equals -3. The domain is x equals all real numbers. So the domain x equals all real numbers, but it cannot be, I'm sorry, but it cannot be the asymptote x equals 1. So it cannot be 1. And the range, I'm going to do it in red, the range is the y being all real numbers, but y cannot be the asymptote, -3. So that is what they're asking for. The asymptotes, we got both of them right here, the vertical one and the horizontal one. And we also have the domain, all real numbers, but it can't be the asymptote, and the range, all real numbers, but it can't be the asymptote. And which one is it? Well, we have x equals 1, that's not it, that's it, or any of these could be it. Okay, how about y equals -3, y equals -3, okay, so that doesn't help us. The domain, all real numbers except y cannot be -3, nope, that's silly. X equals all real numbers except x cannot be 1, that's exactly right so far, right? It cannot be this asymptote, so it cannot be 1. The range, all real numbers except y cannot be -3. So option B is the correct answer this time. Once again, the domain are your x values, and as you can see, this graph does go to the left forever. And as you go from left to right, it does go to the right, and then all of a sudden it infinitely approaches that asymptote value, right? And it continues over here forever. So the domain, it does go to the left and right forever, but it never actually touches the x value of 1, okay? The range are the up and down values, right? The y values. This does go up forever, it does go down forever, but we know that it cannot be that y value of -3. So I hope that little explanation helps. Number 9, you want to solve each inequality or equation. So we have an equation for number 9, an inequality for 10. They want us to check our solutions. And again, if you're confused with fractions, you could get rid of fractions. How do you get rid of fractions? By multiplying everything by the denominator of the fraction that you want to get rid of. Or if you really wanted to, you could multiply all the fractions by the LCD, and that'll get rid of all 3 fractions at the same exact time. Me personally, I like to just take it slow and easy and get rid of 1 fraction at a time. So I'm going to multiply by 2h, and again, everything by 2h. And you'll see, well, first of all, notice that I put the 2h up here in the upper numerator position. Don't put it at the bottom, it's incorrect. You have to put it up here because that's when the 2h up here cancels with the 2h down there. So that cancels. And then over here, we actually have 5 times 2h, which really means 5 times 2 times h. And because of the multiplication, I could cancel that h with that h. So I actually got rid of 2 fractions at once. But what is 5 times 2? That is 10. Okay, so let's write what we have left over. We have the 1 that was right here, plus, let me bring down that plus, and then we have 5 times 2 is 10. It is equal to, now notice this, the 2h does not cancel with anything down here. Even if you're thinking, oh, I could cancel that h with that h. No, you can't. Why not? Because there's subtraction down there, right? It has to be pure multiplication in order for you to cancel items from the top and the bottom. So anyway, right here we have to actually just multiply 2h times 3, and let's rewrite this thing. We end up with a 6h up on top over the binomial h minus 1. So let's clean this up a bit. What do I mean by clean it up? It says 1 plus 10. We might as well write it as 11, okay? 11 equals 6h over h minus 1. So we have this equation. Again, if you don't want that other fraction, let's get rid of it by multiplying by the denominator of that fraction. So I do have a binomial down here, h minus 1. Let's multiply by h minus 1. That way it'll cancel out. It'll completely cancel out. But then again, you have to multiply everything in your equation by that denominator, h minus 1. And there's only one other side, one other item, which is 11. So let's multiply that by h minus 1 as well. And of course, we're going to distribute 11 times h is 11h. 11 times negative 1 is negative 11. Bring down the equal sign. Bring down what's left over, the 6h. So we almost have h by itself. All we need to do is move the 11h over to the other side. We will end up with negative 11 equaling negative 5h. Final step, divide by negative 5, divide by negative 5, and you will get h equals, because that cancels out, h equals positive 11 fifths. H equals positive 11 fifths. That is your answer. It does say check your solutions. I would just, if you're in a rush, just make sure that when you plug it in, you don't end up with 0 in the denominator. So if I would have gotten h equals 1, I know that that would be an extraneous solution that would not work because 1 take away 1 is 0. If you plug in on 11 fifths right there, you're not going to get 0. 11 fifths is not going to be 0 in the denominator. Same thing here. Multiplying it by 2 is not going to change it to 0. So it looks like that's our answer. Let's find our answer. There it is. Option D, 11 fifths. Now let's go to the inequality. So on this one, I'm going to take a slightly different approach just to show you the different ways of doing these problems that have fractions in them. Instead of getting rid of the 4 over p by multiplying everything by p, and then getting rid of this by multiplying by 3, and getting rid of the 1/5 by multiplying by 5, let's get rid of all 3 fractions at the same time by multiplying everything by the LCD of p, 3p, and 5. Okay, so what would that be? That would be 15p. 15p, 15p, 15p. But of course, if you like it the way we did it the previous way, getting rid of 1 fraction at a time, go ahead, totally fine. Okay, right here we're getting rid of all 3 fractions at the same time. This p cancels with that p. You end up with 15 times 4, which is 60. Okay, the 15 up here divided by 3 is a 5, and the p cancels out as well. And of course, 5 times 1 is 5. So you really have 60 plus 5. And you know, this is an inequality, but it really doesn't matter. You could treat it like if it were an equation, all right? You could treat it like if it were an equation. The 15 divided by 5 is 3, so what do we have? We have a 3p. So we really have a 60 plus 5, that's 65, equaling 3p. I guess you could put a less than symbol, but now we're going to keep it as a, pretend it's an equation, all right? Let's continue working here. Divide by 3, divide by 3. So you get p equals 65 over 3. P equals 65 over 3. So this is what we call a critical point, right? Because it's an inequality, our p-values are either going to be above this 65 thirds or below this 65 thirds, okay? And this 65 thirds, just so you can know, is, with a calculator, about 21.7, okay? Anyway, how do we get other critical points? Well, what we have to do is go to the denominators, this p, and set it equal to 0, okay? Because we need to determine whether it's going to be either above 0 or below 0, and set this denominator equal to 0 as well, which it's really not going to make a difference. If you say p equals 0, then there's nothing to solve. That is your answer, right? And if you go 3p equals 0, and you divide both sides by 3, it still says p equals 0. So your critical point is p equals 0. And like I said before, you want to determine whether your p-values are below 0 or above 0. I just want to take one moment, and like, let's say this, instead of 3p, let's say it said p plus 3. Then you would have to say p plus 3 equals 0, and you would solve, and your critical point would be p equals negative 3, okay? So again, we got our answer, pretending it was an equation, 65 thirds, and we got our critical points by setting the denominators equal to 0. In this case, it's the same critical point. So now I need to go to a number line to determine where the area of my answers are at. Okay, so we know that 65 thirds is a pretty big number over here, and the other critical point was 0. So what we need to do is test some values. Okay, I'm going to test a value like, let's say, negative 1, okay, which is clearly on the left side of 0. Okay, so if I plug in a negative 1 into p, that'll be 4 divided by negative 1. That is negative 4. And I'm just going to write it over here, negative 4. And then put a negative 1 right there. 1 over 3 times negative 1, that'll be a negative 1/3. So you really have negative 4 take away 1/3. And I just realized that my audio is messed up. Sorry about that. I had to plug in my mic again. My bad. Anyway, we are plugging in a negative 1. So we got negative 4, we got negative 1/3, and we want to see if it really is less than 1/5. And that is absolutely true, less than 1/5. Because you owe 4, you owe 1/3, that's going to be a negative number, and negative numbers are definitely less than positive numbers. So this answer at negative 1, yes, it works. That means that all of your answers are going to work over here. So your answers are on the left side of 0. Okay, so you should technically test a point in between, okay, to see if it's working. So just quickly, let's test positive 1. Okay, so if we plug in a positive 1, you got 4 plus 1/3, because plugging in a 1 won't change that 3. So 4 plus 1/3 is 4 1/3. Is that less than 1/5? No, of course not. 4 and 1/3 is not less than 1/5. So that's a no. That doesn't surprise me. And let's now test a value that's over here on the right side of this critical point, 65/3, which is about 21 point, what was that, 7? That doesn't matter. Let's pick any number on the right side. I'm going to pick the number 100, let's just say, okay? So if I plug in 100 for P, I'll have 4 over 100 plus 1 over 300. Let me actually write that out. 4 over 100 plus 1 over 300. And is that less than 1/5? Well, if you do the math right there, yes, it will work. It is definitely less than 1/5. I mean, you'd have to get a common denominator of 300 if you wanted to switch it up. So that'd be 12 over 300 plus 1 over 300. That is 13 over 300, and that's definitely less than 1/5. If you go 13 divided by 300, you'll get the decimal number 0.04, and 1/5 is 0.2. So it is true, okay? So what does that mean in terms of our visual over here? It is true on the right. So your answers are apart from each other. The answers are apart from each other, not together, which means it's not going to be a compound inequality written together. It's going to be separate with the word or. So this inequality represents P is less than 0, and this inequality represents P is greater than 65/3. So B is your answer. Number 11, using the formula A equals PERT, P times E to the R times T, how much money would you have after depositing $1,000 in an account paying 8.5% interest? Well, what we need to do is identify what is the principal. This is what you're starting with. This is the P, the principal value. Okay, so A is the amount. So let's begin by writing it in. We have A equals 1,000. That's our initial principal amount invested, times E, times the variable E. Everybody has the E button on their calculator, to the power of R. Now here's the deal. When you write your R, you have to write it as a decimal. So move that decimal over 2 places, you have 0.085. So it will be E to the power of 0.085 times T, which is really times the time. How much time? It says after 6 years. So you can put times 6 right there. Okay, and again, this is going to be your amount. So after 6 years, what's the amount going to be? All you got to do is type this into the calculator and you will get your final answer. So I will show my work here. The 0.085 times 6 is 0.51. So now let's actually type in, if you type in E to the 0.51, you'll get 1.66529, and of course it continues forever, but I'm just going to stop right there. And then multiply that by 1,000. That really means that you move your decimal place over 3 times, 1, 2, 3, and boom, there is your answer, $1,665.29, which is option B. And that concludes our second page, and this video is already ridiculously long. So I'm going to stop this video right here, and I'll explain the next page, pages 3, maybe 3 and 4 on the next video.